Hi, in this video we will learn a new product of two vectors from R3. It's called cross product and it always only makes sense for vectors in R3, vectors with three components. Okay, let us start with the definition. So, give me two vectors in R3. So means that we have three components for U and three components for V. We two vectors in R3. Then U cross V, the cross product of U and V is a vector in R3. And that vector is given by this. So first component of that vector is U2 times V3 minus U3 times V2. The second component is U3 times V1 minus U1 times V3. And the third component is U1 V2 minus U2 V1. Well, yes, it is not easy at the first glance to see what is happening. To have a pattern in mind to do this computation, the cross product, you can get help from the following things. So so how to memorize or a pattern. So first thing first is that you put the components of vector u in the first row and then components of v in the second row. So it will be v1, v2, v3. Then to find the first component, what we do is that we ignore the first column. The first column here is this. You ignore it. What you will get is U2, U3, V2, V3. Okay? That is what will happen for the first component. So you forget the first column. For the second one, you forget the second column. So you get U1, U3, V1, V3. Okay? And for the third one, you forget the third column. Oops. You forget the third column. So you will have U1, U2, V1, V2. These are 2 by 2 what's called matrices, but we will get back to that later in the course. But at this stage, what I want to learn is this. In all three components, you have a two rows, 2 columns, so a matrix of 2 by 2. You do this operation, multiply. These elements are called the diagonal elements. These elements are called off-diagonal elements. The operation we are doing has a name, it's called determinant, but you multiply the diagonal minus multiply the off-diagonals. Multiply the diagonals, multiply off-diagonals. U1, V2 minus V1, U2. And for this one is U1 v3 and v1 u3. There is one thing you have to be careful. In the middle part, you always put a minus and multiply everything with minus. So that will give you the components you're looking for. Basically, for the one who know the determinant, these are the determinants of these submatrices. We will get back to this later. Let's just do some examples and then we will see how everything goes. Example, find the given cross products. First one is 1, 2, 0 cross 2, negative 1, 3. And then the second one is I plus j minus k cross 2i minus 3k. Okay, so let's just compute these ones. Remember, you have to make 3 components. First component, second component, third component. What you do is write 1, 2, 0, 2, negative 1, 3. And then, well, for the first one, ignore the first chord, the first column, yes? This was 2. Ignore the first column. This will give us 2, 0, negative 1, 3. For the second one, ignore the second column, so it will be 1, 0, 2, 3. But don't forget to put a negative sign there. For the third one, you put 1, 2, 2, negative. Okay, what do we mean by those things? So this means that multiply the diagonal elements. Here's 2 times 3 minus multiply off diagonal elements, 0 times negative 1. Here, multiply diagonal elements, 1 times 3 minus off diagonal elements, 2 times 0. But everything needs to be multiplied by a negative sign for the middle one, only the middle one. And the third one is you multiply these two, 1 times negative 1 minus 2 times 2. Okay, let me get back to black. This is 6 minus 0 is 6. This is 3 minus 0 is 3. There's a minus sign. This is negative 3. And this negative 1 minus 4 is negative 5. That is the cross product of these two vectors. Well, what will happen for this one? Okay, let's just turn this first to the component version. So it will be 1. The coefficient of I is 1. Coefficient of j is 1. Coefficient of k is negative 1. Cross 2. There is no j. That means the coefficient of j is 0. And then the coefficient of k is 3. Then this gives us 3 components. How do we find it? I will follow exact same steps. First, put this guy in the first column, first row, and the second one in the second row. Ignore the first column. Then put it 1, negative 1, 3, negative, sorry, 0, negative 3. The second one is you forget the second. What is this? There's nothing there. Okay, you ignore the second column. The remaining is 1, negative 1, 2, negative 3. Multiply everything by a negative sign. And for the third one, you forget the third column and then put the rest there. So it will be negative, sorry, 1, 1, 2, 0. Okay, by these numbers, what do we mean by those numbers? So what we mean here is that multiply diagonal elements, so 1 times negative 3 minus multiply off diagonal elements, negative 1 times 0. Diagonal elements minus off diagonal elements. Diagonal elements minus off diagonal elements. And that gives us the final result. So this is negative 3 minus 0 is negative 3. Negative 3 plus 2 is negative 1 times another negative sign up front, that's 1. This is 0 minus 2, this is negative 2. And that is the cross product of these two vectors. Okay, well, let me just add a remark here. First thing first is that unlike the dot product, cross products only defined for vectors in R3. So 1, unlike the dot product, the cross product is only defined for vectors with 3 components. That's the first thing. Only vectors from R3 we can cross product. The second thing is that the cross product is a vector. The cross product of 2 vectors from R3 is a vector in R3. Remember, the vector, the dot product of 2 vectors were a number, but cross product will give you 1 vector, 3 components, and that is those are 2 main differences between dot product and cross product. So just quick wrap up, we define what is the cross product and cross product between two vectors from R3, and then we did some examples.